Hello everybody, in this video we are going to have a look at some more trig graphs and what they could potentially look like. So in this particular video, what we're going to have a think about is graphs where we just add some numbers or take some numbers away. So we've got y equals sine theta in front of us. Well, what would happen if we had y equals sine theta plus 1? What would that look like? Well, what this means is every outcome we did generate before for the regular y equals sine theta graph, all we've got to do is add 1 to it. So let's have a think about what that might look like on our graph. So if we had a 0 generated before, and so let's just be clear about this, that graph is y equals sine theta. Well, y equals sine theta plus 1, we've got to add 1 to it. So that is going to move up to 1. And if at 90 degrees sine theta gave us a 1, well, now it's going to give us a 2, isn't it? Because we're doing y equals sine theta plus a 1. So what's happening here is every single point that we did have, we're adding 1 to it. So in essence, in a transformative kind of way, we're shifting this graph up 1. We're doing a vertical raise of 1. So let's join this up and show you what it looks like. So this blue graph you're seeing drawn now is y is equal to sine theta plus 1. And it might help to think about the midpoint, the middle of this graph, where it used to be the x-axis. Where's that now? And of course, it is at the line y equals 1. So how about if we did a different one now? What about y is equal to sine theta minus 2? Well, this one will, of course, move down 2 places. Every point that we did generate for sine theta, now we're going to take 2 away. So we better extend our axes. Let's put a minus 2 on there and a minus 3 on there, and then we can mark some points. So if our original red y equals sine theta graph gave us a 0, if we take 2 away, we're going to be at minus 2. If it did give us a 1, well, now it'll give us a minus 1. If it gave us a 0, we've already seen this once, it's going to give us a minus 2. If it used to give us a minus 1 and we take 2 away, it will now generate a minus 3 for us. So this is the pattern, and this is going to continue on forever and ever and ever. I'll finish drawing it at 720, just like the other graphs. And there we are. Okay, so now let's join these up. This is your graph of y equals sine theta minus 2. Now we call this dotted line the principal axis, which is now shifted down 2 places. So of course that principal axis for this example is y equals minus 2. Now let's model a cosine graph now, just so you've seen something a bit different. And how about we make this a bit more challenging? If this red graph is y equals cosine theta, well, let's think about y is equal to 2 cosine theta plus 1. We'll combine our amplitude with this phase shift and see what happens. So we're certainly going to need to extend our axes. We're going to be moving it up, and we're going to be stretching it and raising the amplitude to 2. So let's carry this on a little further. Let's mark in 1, 2. We might not have enough space here. Okay, and well, we'll see what happens. Okay, so first of all, we are definitely going to be moving this thing up 1. So if we're moving it up 1, let's draw in that principal axis right now. Rather than being at 0 or the x-axis, it is going to be here. Okay, so we're going to be rotating around, or oscillating around, I should say, the line y equals 1. Okay, now we know the amplitude is going to be 2, right? So we are going to oscillate between 3 and minus 1. So every time we move, we're going to be up as high as 3 at the maximums and as low as minus 1 in the minimums. But let's think about that as we go along. Let's now think about what happened to the original graph. So the cosine theta graph had a 1 when we had theta is 0. So what we're going to do is double that and plus 1, right? Okay, we're doubling it because of the 2 and plussing 1 because of the plus 1. So Doubling it to get to 2 plus 1 gets us to 3. At 0, doubling 0 gives us 0. And then we're going to plus 1. Well, we're going to get to 1. Minus 1 doubled is minus 2. And then we plus 1. And we're going to get back to minus 1. That point is actually going to stay the same. At 270, we had 0. So we double 0. We still have 0. And then we plus 1 to that 0. Well, that brings us up to 1. At 360 degrees, well, we had a 1. So if we get a 1 times 2, we get 2 plus 1. Well, we're going to be back at that high point of 3. So you can see exactly what we said has happened. This thing has stretched scale factor 2. The amplitude is 2. And we've moved it up 1 place. So if we just continue this on, we'll have a graph that looks like this. This blue graph is y equals 2 cos theta plus 1. Should we finish it off? Let's have the 450 point, the 540 point, the 630 point, and the 720 point. So between a boundary of 0 and 720, y equals 2 cos theta plus 1 is the blue graph in front of you now.